Hello guys, in this video I'm gonna show you how to find the angles of a triangle with known vertices. Okay, any triangle of course has three vertices, three like heads. Okay, so if you know the coordinates x, y, z of that of each head, each vertices, okay, each vertex, then there is a way to find the angles, all the three angles actually in that triangle. So let's assume, for example, we have a triangle like that. And let's call these vertices ABC, A, B, and C, whatever you like. Okay. So the idea came from the fact that if you have two vectors, okay, then you can find basically the cosine of the angles of the angle between these two vectors, okay, using some formula. So basically the formula is like that. If you have like two vectors like that, let's write them as v1 and v2 with an angle theta between. So cosine theta is equal to v1 dot v2, the dot product of v1 and v2, divided by basically the length of v1 multiplied by the length of v2. Okay, that's what we're gonna do right now to find these angles of that triangle. So we have here three vertices with known coordinates A, B, C. Okay, and we're gonna find the angles between them. So we have here theta 1, we have here theta 2, and we have here theta 3. Okay, so let's find out how to do that. We know A, it is 3, 1 minus 2. We know B, it is 5, 2 minus 1. We know C, it is 4, 3 minus 3. Okay? That's basically what we have. Okay. So let's see what we should do. We have here points. We have here vertices. We have here coordinates. We don't have the vector itself. Okay? Remember, a vector is basically some, a vector is something that connects two points together. Okay, so let's call this vector AB, which goes from A to B, and let's call this vector VC, which goes from B to C, and let's call this vector AC, which goes from A to C. Okay, so what's AB vector? Simply a vector connecting two points. It's basically is the destination point minus the source point. The destination point is B minus the source point, which is A. So that will be 5 minus 2. It is 5 minus 3. I'm sorry, it's 2. 2 minus 1, it's 1. Minus 1 minus minus 2 will be positive 2. So it will be 1. 2, 1, 1. Okay. Let's see AC. That will be C minus A. So 4 minus 3, it is 1. 3 minus 1 is 2. Minus 3 minus minus 2 will be positive 2. So it will be minus 1. And finally, BC. It is C minus B this time. No more A's. So let's see B, C minus B. So 4 minus 5, it's minus 1. 3 minus 2, it is 1. Minus 3 minus minus 1, so it's minus 2. Okay. We're going to start by theta 1. Okay. So cosine theta 1. Theta 1 is between AB and AC. So theta 1 here, it's the angle between AB vector and AC vector. Okay. So cosine theta 1 is basically AB dot AC divided by the magnitude of AB multiplied by the length of the magnitude of AC. Okay, so let's have the dot product between AB and AC. Dot product is very simple. We just multiply the corresponding, elements. So we're gonna multiply. So we're gonna here consider AB and AC. So we're gonna multiply. Let's do that with another color. We're gonna multiply the 2 by 1. So it's 2 by 1 plus 1 and 2 plus 1 and minus 1. And for the length, it's very easy. Square root and then square every element in the vector. So for AB, it's 2 square plus 1 square plus 1 square multiplied by, same for AC, 1 square plus 2 square plus minus 1 square, which will be 1 square as well. Okay? So minus 1 multiplied by minus 1 will be positive 1. All the time, the minus 1. So let's continue on that. So let's go back to our normal color now. So cosine theta 1 is equal to 2 plus 2 minus 1. And this will be square root of 6. And this will be the square root of 6 again, which is good. Now we have here, that will be 6. And that will be 3. So it's half. So we're gonna search for the angle that have a cosine equal to a half, which is 60. So theta 1 equal to 60 or pi over 3. So if you want to go by radians, I usually go by degrees. Okay, good. So that's theta 1. Now I'm gonna do like some trick here. The normal flow is to go to theta 2. No, I'm not gonna go to the theta 2. I'm gonna leave it to the end. I'm gonna do theta 3. Okay, and you're gonna know why I skipped theta 2 for now, because that's the trick. That's why I did this video for you guys. So theta 3. Theta 3 is between AC and BC. I'm gonna go number 2 to theta 3. So we can get some very little correction. So remove the cosine back here. So theta 3 is basically the angle between BC and AC. Of course, the order doesn't, there is no order. So cosine theta 3 is equal to BC dot AC divided by BC magnitude or length, AC magnitude or length. Okay, so let's see. So we're gonna multiply by BC and AC. Luckily, they are just underneath each other. So 1 minus 1 plus 2 and 1 plus minus 1 multiplied by minus 2. BC square root of minus 1 square plus 1 square plus minus 2 square. And AC, don't do it again. You have it already. It is 6, square root of 6. Okay. So cosine theta 3 is equal to minus 1 plus 2 plus 2, because minus will multiply by minus will be positive. Okay. And again, here we have square root of 6, square root of 6. So 3 divided by 6, it's another half. So theta 3 is equal to 60 again. Now you can find theta 3 with the same way, or you can go back to our, kindergarten math. We know that the summation of the angles of a triangle is equal to 180 degrees. Okay, so number 3, we know that theta 1 plus theta 2 plus theta 3 is equal to 180. Any triangle is like that. So we know theta 1 is 60. We know theta 3 is 60 again. So basically, theta 2 is equal to 180 minus 120, 60 plus 60. So that will be 60, of course. It has to be. And I'm sorry, this is theta 3. And that's it. Okay? Now, if we wanna check, we should do the same step again. We should also have, if we do the dot product and we apply basically the same concept to find theta 3, we should find, we should calculate also 60, right? Let's see, let's check. So where is it? Theta 3 is theta, I'm sorry, theta 2. I'm sorry, this is theta 2, not theta 3. I'm very sorry for this. That's correct. Theta 2. Okay. So it is between AB and BC. So theta 2, just to check here, we finished the the problem, just checking. That's a trick. That's why I did this video. Let's see. So theta 2 is between AB, right? And BC. So let's do it. So cosine theta 2 is equal to AB dot BC divided by AB magnitude, BC magnitude. Okay. So ABBC, let's do that. ABBC, so these two here. So you have 2 minus 1, 2 multiplied by minus 1 plus. You have 1 and 1 plus. You have 1 and minus 2. And you have 6. We did this before, so I will not repeat that. So equal to, so cosine theta 2 is equal to minus 2 plus 1 minus 2 divided by 6. That's minus 3 over 6. That's minus half. This is not positive half. So theta 2 is equal to, if you did this like on calculator, it should be minus 60 degrees, which is wrong. Because now if we apply what we know is that the addition of all the angles in the triangle should be equal to 180. It will not be the case. 60 theta 1, theta 3 is 60, and now theta 2 is minus 60. That's basically 60. That's wrong. That doesn't equal to 180 degrees. What is the problem? Why didn't keep correct like the other guys? Because we made a mistake. We defy. We violate the definition of the formula. So let's go back to the formula that we use. This is the formula, guys. And this was the definition of theta. It is the angle between two vectors. These vectors coincide in the tail or coincide in the head. So you can apply this formula in two cases. Only two cases. Let's draw them. So this is the first case here. And I'm going to do the second case. When you have the two vectors, let's just make it same. V1, V2. And now both are heading to theta 1. Okay? You cannot apply it in that case. Or let's see, yeah, this case. So look, AB is going in that direction. So that's his, that's the head here of AB. But this is the tail of BC. They should be either going in the same direction or going in or going out. Okay? That's why it was wrong. But we can correct this in a very simple way. Okay, just extend AB like that. Extend AB like that. Okay? What's actually the theta that we calculated? That's basically what we calculated here. So that's this one. So if you apply 180 for it, so it will be this angle, the 120 angle. Okay, the 120 angle. So to apply the formula and define, so with this, what we did here is we are not finding theta 2. We are finding actually the 120. Okay, So to correct the formula and still use it, we should add a negative. So if let's write this here. So if the two arrows or two vectors are making like that, so or like that, cosine theta is equal to minus, let's call this v1 v2, v1 v2. So it should be minus same v1 dot v2, magnitude of v1, magnitude of v2. Just add minus. That's what we're gonna do here. So I'm gonna use the same, but I'm gonna put a minus. I'm gonna put a minus, 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 minus again. So that will be half. So it will be positive 60. Okay, and now it's gonna be 180. Okay, guys, that was basically the trick. That's why I did this video for you, because yes, the problem is easy, but when you apply blindly, like, and that's a mistake that you might do. I did it by the way. So if you apply blindly the equations, at some angle, it will not add up. You will feel something is bad, because basically if you add, you're gonna find that the summation of the angles are less than 180 degrees. Okay, and that was the reason. Okay, guys, thank you very much for watching. See you in another video. Bye.